Hi guys, this is James from MAT-10 with Warsinski, and what I'm going to try to do for you guys, and this is my first time doing this, is I'm going to try to go over some of the review questions that we covered in SI and hopefully clear any confusion that any of you may have. And if my goal for the future is that if any of us have any particular problems that need to be explored in depth, I'm going to try to find the free time to help out with that. We'll see how it goes. But I wanted to start as an example with the difference quotient problems that we went over in SI. And so I'll start with the first question we were given, number 1, which was the function of a of x equals x squared minus 3. And what we were asked to do was to find the difference quotient of this function. And in order to do that, you need to know the formula for the difference quotient, which is f of x plus h minus f of x over h. And the real trick to being able to do this problem is setting up your problem. Once you've set up your problem, it's just basic algebra. And so you need to understand what you're doing is you are taking your function and you are plugging it into this formula in an altered form in the first part, and then in its original form in the second part. So let me denote that here with these brackets. And so I'll go ahead and start setting up that. First thing we'll do is plug our, getting used to using this, plug our original function into this difference quotient formula. And in order to do that, the x plus h part is going to seem a little confusing at first. You're kind of plugging your function into this difference quotient formula and plugging part of this difference quotient formula into your function wherever you have an x. So it will look like this. Anywhere where you have an x in your original function, you will instead plug in x plus h for this first part of the formula. So we have, I'll just kind of write it off to the side here. We have x squared minus 3. Now, this is where we have our x, but instead of x, we will have x plus h, because, like I said, that's what we're plugging in. So I will go ahead and write that out. X plus h squared, just like we had in our original formula, minus 3. This is the first part of our difference quotient formula, as noted here. And we will go ahead and write in the second part, which is just our original formula, or our original function, sorry. Minus x squared minus 3. Our original formula, and don't forget to put parentheses or brackets or whatever you like, is this right here. And the reason being is that you will have a different sign here if you don't put those parentheses. See, this negative here makes this a positive when you go through and do the formula. So let's move on. Begin by distributing, oh sorry, I forgot my h here. Begin by distributing your square of x plus h. So what is x plus h squared? Well, you can think of it as x plus h times x plus h, if that simplifies it for you. X times x is x squared. X times h is going to be xh. And h times x, well, we'll just write in the same order, x plus h, or xh, rather. And the final term of foiling this out is your h squared. We can combine this as x squared plus 2xh plus h squared. And as long as you have a grasp on the foiling, then you can just skip that part, do it in your head, and write it as x squared plus 2xh plus h squared. Don't forget your minus 3. And go ahead and just bring down your x squared minus 3. Or go ahead and distribute that negative, and it distributes into the positive x squared as minus x squared plus 3 over h. And from here, you just need to recognize your canceled terms that'll cancel out with each other. You have a positive x squared that will cancel out with a negative x squared. You have a negative 3 that will cancel out with a positive 3. So what you are left with is h squared plus 2xh over h. And you could think of this as a three-way cancellation of your h to take an h out of everything, but you are in fact skipping a step when you do that, and I will go ahead and elaborate that step here. H squared plus 2xh, you can easily see that you can factor out an h out of both of these terms. And what you are left with is h times h plus 2x over h. Now you can easily cancel this h out and get rid of your denominator altogether, and what you are left with is, I'm just going to write this in a different order, 2x plus h. Now this is your difference quotient of your given function. Go ahead and box that as your answer.